working on parallel lines, so today we're going to work also on parallel lines. Now this particular idea is transitivity of parallel lines, because if two lines are parallel to the same line, then they have to be parallel to each other, so that works out like that. Unfortunately, on the screen I can't show the third dimension, but it doesn't even matter if all three of the lines are in the same plane. Okay, they can be in different planes. Could you go put your hoodie in your locker, please, and then you can just take that with you so they know why you're in the hall, and then take your homework out. Okay, so okay, do you have your homework sitting out? I don't know where my book is. Okay, so right, I had Hammy, but and I talk to me before you leave the classroom so we can make arrangements for that, because we're at the end of the quarter. And okay, so two lines are parallel to the same line, then they're parallel to each other. Even if you can imagine this M coming out of the screen and like hovering right above it, okay, they could still be parallel to each other, even if you brought it out into the third dimension. For those that are in the class, I can show that to you. People online that are listening, I can't really show you on there, but I can show you in here. I've got the big things worked out. So if I have two parallel lines on the floor, okay, you can all see them, and so they're parallel, they're in the same plane, but I have this other one that's hovering out here, okay. Notice we could draw a line, we could draw a plane that went from here down to this bottom one. So they would be parallel. These two would be parallel. They are both parallel to this same line, so therefore they're parallel to each other. Okay? So parallel to the same line, therefore parallel to each other, even if it's not in the same plane, although it certainly fits if they are in the same plane. All right, so right down there like that. And you could go put your hoodie in your locker, please. Okay, thanks. So this picture, what we can do with this one is we can determine which line can be proved parallel because of specific pieces of it. We've got 4 transversals going here. Okay, each one of the transversals is a transversal between 2 different lines. So we need to think about which 2 lines would be proved congruent based on which angle. So the angles will be right up against the transversal. So for example, angle 1 and angle 3.
Is this the same factor from yesterday?
I'm sorry?
You're saying the same factor from yesterday?
Yeah, same factor from yesterday. So you should have those out. I told you yesterday we were going to finish it. Okay, so I can draw on it from there. We'll take a look. Should have 23 are complete. All right. So if we look, the first one said angle 1 and angle 3, right? So angle 1 and angle 3 are right up here. Here's angle 1 and here's angle 3. So they are along line A. So line A we're thinking of as being the transversal. So that would mean what 2 lines are parallel if angle 1 and angle 3 are congruent. So angle 1 is congruent to angle 3 means which 2 lines are parallel? Abby? So our choices are A, B, C, and D. So if 1 is congruent to 3, B and C are going to be parallel lines. B is parallel to C. Okay? Because 1 and 3 are both related to this as being the transversal. So it's transversing between B and C. Let's just identify a postulate real quick. What's the relationship between 1 and 3? What kind of angles are they? Yep. They're corresponding. So the reason that B is parallel to C is because of the corresponding angles postulate. Actually, the converse. Corresponding angles converse. You have to have converse in there. Whenever the converse is all ended with, then the lines are parallel.
Do you have any Converse?
No.
I'm sorry?
Do you have any Converse?
No.
Shoes?
Nope. But I'm done. Okay. Here, what's the next one they're telling us? Angle what and angle what?
Angle 1 is equal to angle 15.
Congruent.
Congruent.
Congruent to angle which?
15.
15. So if we're looking at angle 1 as it compares to angle 15, yes.
They're alternate exterior.
Okay, alternate exterior angles. So our reason will be alternate exterior, and yes, you can abbreviate like this, angles converse. Okay, but what lines are parallel then?
A and D.
A and B. Good. A parallel to B. Good job.
Oh my gosh.
Read what's the next one? Which two is it
6
saying to
and 12.
compare next?
Angle 6 is congruent to angle 12.
Angle 6 congruent to angle 12. So if we're looking at 6 and 12,
That means 8 is congruent to angle 10.
not angles.
Oh,
we're looking for
lines.
which ones are parallel lines. So which ones?
C. Is it C?
Okay,
Oh,
so,
A.
so C is the one that's going to be our transversal because they're right up against that
Oh.
one. So if this is the transversal, which two lines are parallel?
A.
A and
D.
D. A is parallel to D.
Oh,
It's going from one to the other. Those are the parallel ones. And what's the name of, what is their relationship? We need to have a reason because of.
Wait, I have a question.
Yep.
What does,
You know it?
what does like B stand with the two lines and AD was just like,
This means is parallel to. B is parallel to C.
oh,
Okay, so each one of the facts is enough to show us that one group or one pair of lines is parallel. So we're identifying which pair, and then I'm adding in what reason would we give to go along with that. Okay, don't know? Do you know? Not consecutive interior, but definitely interior.
Corresponding. Alternate.
No, don't yell, please. Thank you. Jordan, back to you. They're definitely interior, but what kind of interior? Alternate interior. They're on opposite sides of the transversal, so they are alternate. They are inside, so they're interior. And it's a converse because it ends with our conclusion being that you have parallel lines. Question, Isaiah?
Is 12 not an exterior angle? Oh, no, it's inside. Never mind.
Okay. All right, so wait, ask your question again, Sierra.
I thought 12 was an outside angle, but I just realized that the 13 is the outside angle, right?
So 12 is an outside angle if you're looking at transversal B. Okay, but since the other angle that we're looking at is 6, you have to consider C being the transversal because it's the one that they both are relating to.
Mhm.
So that would be our transversal. So if this is the transversal and these are the lines, then it's inside for those lines.
Mhm.
So it can be interior for some things and exterior for another. So it's important to look at the pair of them to figure that out. And your notes need to be out, sitting there, ready to go when you come back. Yes.
so what's the difference between corresponding and converse?
Okay, corresponding angles are the relationship between the two angles. The converse is the theorem that says that that says if corresponding angles are congruent, then the lines are parallel.
So what's the AOT and all that?
Alternate exterior angles converse. I abbreviated a little bit. Because
So what's,
in
all right,
the
so what's the difference between corresponding and that?
alternate exterior, both are on the outside, like these are the parallel lines, these are both on the outside and opposite sides of the transversal. Were you out day before yesterday as well?
Yeah.
So the explanation of that is online as a video. Okay, so I have that, I believe I have it on GradeLink. The links are there, so you can go on to teacher pages, I believe is where I put them. So that you can click on that if you need to. It was for the soccer team because they were out, but then you reap the benefit of it because it happened to be on a day that you were absent as well. Okay, so that should clear that all up, and then you can fast forward me or put me on fast or slow or whatever you need to. What was the other two, Jasmine? The last set. Angle. What's it say? Angle 12 is congruent to angle 10. So I want to identify them so we see them. Here's angle 12. And here's angle 10. Okay, so if we're looking angle 12 and angle 10, use that to help you find what transversal, the ones that it's right along. And so which lines are parallel because of angle 12 and angle 10 being congruent. I'm going to see if I can stick with Jasmine for a minute. Jasmine, do you know which lines are parallel then because of that? Line C and B, good. B parallel to C.
B parallel to C.
And Milo, can you tell me the reason?
The corresponding.
Corresponding, so it's the corresponding angles.
Converse. Oh, converse, yeah. We have both of them.
It's because you got, the conclusion is that you got parallel lines. You started with angles, and then the conclusion was about the lines. If you started with the lines, and the conclusion was that the angles were congruent, then you would have not the converse, but you would have the postulate or the theorem. So you could just say corresponding angles. If you say corresponding angles theorem and it's really a postulate, I'm not going to take off points for that. But if you forget that it's a converse, then I would take something off for that, yes.
What is the difference between the two things?
What, a postulate and a theorem? A postulate is something that you can't prove, and you always start with a postulate, but then you can prove the theorems from that. And you know, sometimes the waters get muddied a little bit as far as, well, was that a postulate or was that a theorem? And I'm not going to pull that and unravel that. Okay, but the converses are the ones that, in this case, that are all ending with parallel lines. All right, so far so good. And we're on this one. It used to let me just draw on there, and now I can't. All right, this is another one of the same type of problem, which can be proved parallel because of the different things that are going on. Okay, so let me grab this copy and let's see if I put that right on my here. This one. Rick, what was the first ones they said? Angle what and angle what?
Angle 2 is congruent to angle 6.
Angle 2 congruent to angle 6. So here's angle 2 congruent to angle 6. So this would be our transversal. Now we don't, in this case, we're going to have to use the 2-letter method for naming angles. So if you, not angles, for naming lines. So we would have to be line, and it would look like this with 2 letters is parallel to line whatever. So if these are our 2 angles, which 2 lines would be congruent, Anaya?
That was what it is.
Well, A is not an entire line.
Oh,
A to what is the line you're taking? Are you thinking about AB or are you thinking about AD? AB. So line AB is parallel to line
CD.
CD. So these two being congruent, this is the transversal it relates to, so it's connecting this top one and this bottom one. And does anybody have the reason for that one? Nico, what do you think the reason is?
Is it,
Alternate
Interior.
interior. Angles, it is a converse though. Because our conclusion is parallel lines. Let's get, what was, Abby, what's the next one that they were asked about?
will be able to meaning.
Angle 1 congruent to angle 5. So I'm gonna mark these on here. Usually if you don't have colors, like a 1 would go with a 1, like 1 swoop would go with 1 swoop, and 2 swoops would go with 2 swoops. So I'm gonna start doing that consistently. So angle 1 and angle 5 also kind of looks like it's on the same transversal, but we've got to be careful as far as which two lines are connecting it with those two.
Would it be AB and CB?
You said AD and CB, yes. AD and CB. Because here it's alternate interior. If this is the transversal and here are our parallel lines, because it's alternate interior that way. So again, alternate interior angles converse. Okay, Lizzie, what's the next one we're asked about? Yeah, now all these reasons are actually going to be alternate interior angles. So 8 and 4. Okay, I say yes, not back yet. Shane, what do you think? Which lines would be parallel because of 8 and 4? Right now, which lines? Like our conclusion on these are all that the lines are parallel. So which line is parallel to which line? Because you look like, for example, for the red one, we look at the transversal, but you also look what it's connected to.
So if
it's
you put that
connected
little
up
curve,
to this one and that one.
I have a question.
Yep.
If you put that little curve, is that just to see what's connected, like what it's connected to?
It doesn't really mean that, but it can help if you're thinking, if you think of it as being connected.
So like, would it be B and C?
So with these.
I mean B and
with these, so it connects this transversal to this one, right? So this connects the transversal to which line that might be parallel? To, you have to use 2 letters. D, B is the transversal, but it connects it with the other one it connects to. D, A. So DA is parallel to what other one? Sheen, and don't give him help right now. BC, yep. Because it's kind of connected to those. All right, and then our last one, Angelina, which one? What's the last one?
What would it be? Would it be an alternate?
Yeah, they're all actually alternate interior angles converse in this particular one. Yep.
So what makes them interior or exterior?
Interior, okay, so here's our parallel lines. So they are inside of the parallel lines, and they're on opposite sides of the transversal, so that makes them alternate and interior.
So all of these ones were external from there.
There was actually not all of them
Not
were
all of them.
exterior, but some were interior, some were exterior, some were corresponding, and some, yeah, so we've got various things happening on that one. All right, so Angelina, what were the last two?
There's actually last one.
Okay,
So it's angle 3 congruent to angle 7.
angle 3 congruent to angle 7, so I'm gonna mark that. 3 congruent to 7. Okay, so what two lines, that implies what two lines are parallel then? Angelina, you wanna finish it off?
Yeah, sure.
Mhm.
AB
Uh-huh,
and DC.
good, A, B, and B, C. Great. All right, so that concludes that lesson. Let me stop the recording.